Time for lesson 10.7. Today we'll focus on using the discriminant. So first you're going to have to say, what is the discriminant? So the discriminant of a quadratic equation, if it's written in the form ax squared plus bx plus c equals 0, it's the value of the expression b squared minus 4ac. And if you're going to recall that b squared minus 4ac, that's the part underneath the radical in the quadratic formula. So if I was doing x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, right here, this part underneath the radical, b squared minus 4ac, that's called the discriminant. So we're going to use it to solve some problems, and first I'm going to ask you to think about what it might mean. So, if the value of the discriminant is positive, I want you to predict the number of real solutions. And then in a minute, we're going to draw a graph of a quadratic equation that has that positive discriminant. So all I know is if this value under here is positive, so it could be any positive number. So we'll say x equals negative 2 plus or minus the square root of 25 all over 3. Okay, make it totally up, but that would be an example of a positive discriminant. What's going to happen there? Okay, hope you're going to notice that that discriminant's positive when you do negative 2 plus root 25, which is 5, over 3. When you do negative 2 minus 5, all over 3, you're going to get different answers. You're going to get two distinct solutions. So I'm going to think in this case we probably have two solutions. Anytime that that discriminant is positive, we probably have two solutions. Okay? What if the value of the discriminant is 0? Okay, so I want you to think about that. Again, in the quadratic equation, that's going to look like x equals whatever. This time I'm going to keep negative 2 plus or minus root 0 all over 3. So I want you to think about what would happen there if that discriminant, that value of b squared minus 4ac, if that's 0, then when you do negative 2 plus 0 divided by 3, and negative 2 minus 0 divided by 3, you do not get different answers. But do you have a solution? Yes, you do. So it looks like in this case we would have one solution. Okay, and then for the last one, what if that value of the discriminant is negative? So now this time I'd say like negative 2 plus or minus, let's say root negative 25 over 3. Okay, I don't really care what it is, but it's a negative number. I hope you can see that when you're trying to solve it, and we're trying to take the square root of negative 25 right now in our math careers, we do not know how to do it. We would say there is no solution. So in this case, we have no solutions. Okay, so I want you to be able to distinguish that difference. If I just had a kind of a sketch, if I said something had a positive discriminant, we said from before that has two solutions. So if I made a graph, it could look something like that. I would have two solutions. A negative discriminant, that's when we said there were no solutions. Okay, and that's because that value under the radical is negative, so we can't take the square root of a negative number. So who knows, maybe something like that where it never crosses the x-axis. Okay, and then a discriminant of 0, so there we determined that there would be one solution. Okay, so my graph, maybe it will look something like that, just touches the x-axis once. Okay, so I want you to be able to just tell by b squared minus 4ac by the discriminant, you should be able to figure out whether there's two, none, or one solution. So we're not actually solving these problems, we are just going to figure out how many solutions there are. So x squared minus plus 5x plus 10 equals 0. So today I'm just going to focus on using that discriminant b squared minus 4ac. So in this case, b squared, 25, minus 4 times 1 times 10, I get 25 minus 40. It gives me negative 15. That's a negative discriminant. So if I was solving with the quadratic formula, negative 15 would be under the radical. Okay, since we can't have that, this one has no solutions, so there's none. Okay, if I tried this second one, Again, I'm going to do b squared minus 4ac. So 6 squared is 36 minus 4 times 2 times 3. So 36 minus 24 is 12. That's a positive number. So again, if we had square root 12, if we added square root 12 and subtracted square root 12, we're going to get two different answers. So this is going to have two solutions. Okay, you're probably guessing what the third one is, but let's just do it just in case. So again, b squared, 12 squared is 144, minus 4 times 1 times 36. We get 144 minus 144 happens to be 0. So that discriminant is 0. When we take the square root of 0, we have just 0. Adding it, subtracting it's the same thing. So in this case, we only have one solution. Okay. All right, so let's do a word problem with this concept. A football is punted from a starting height of 3 feet, and it has an initial upward velocity of 40 feet per second. I want to know, will the football ever reach a height of 30 feet? So here we go, the football. Here it's getting punted. I want to know if it's ever going to get up to 30 feet. And we could solve that by finding the maximum like we have done in 10.2, but then there's another shortcut that we can do by finding the discriminant. So here I'm going to plug in everything I know. H, I want to know if the height will ever reach 30, so I'm going to plug in 30 equals negative 16t squared plus, v is my velocity, 40t, plus c, which is my starting height, which is 3. Okay. All right, now this is not in standard form, so if I want to use anything with the discriminant here, I would want to subtract 30 from both sides. Okay, so now I'm going to get 0 equals negative 16t squared plus 40t minus 27. Okay, so right now I don't necessarily want to actually solve it, but I just want to know, is it ever going to actually hit that height? In other words, will this have any solutions or not? So all I really need to do is look at the discriminant, b squared minus 4ac, and check it out. So b squared, 40 squared is 1600 minus 4 times negative 16 times negative 27. So I'm going to try that. 1600, I'll just use a calculator, minus 4 times negative 16 times negative 27. That equals negative 128 when I solve it out. So that discriminant is negative, which means this graph will not have any solutions. So no, it is never actually going to hit 30 feet, unfortunately. Okay, this is what I want you to take away. What is the discriminant and how is it useful? See if you can come up with answers to both of those questions. And nice short lesson for you today.